Good morning, everybody. Thank you for joining us this morning. Usually I'm used to saying good afternoon as well, but I think good morning covers us all today. Like I just said, I am recording this, so you should have seen the notification pop up. Today's presentation will be from Netterman. John will be the presenter, and he's going to be talking about welding fume extraction and the different products that they have to help with that. As always, if you have any questions, go ahead and put them in the chat and we'll review them at the end. So John, go ahead.
Well, thank you for the lovely introduction. I'd also like to introduce my counterpart, Bob Hotchkiss. Bob lives in Southern California and covers Arizona west all the way up to the Canuck border. So anything west of Arizona, New Mexico border, Bob's your guy. Anything to the east of that, I'm your guy. At the end of the day, Netterman is your company to work with. So today we're going to discuss welding fume extraction, or a new term being used in the industry is thermally generated fumes or smoke. We're going to cover today the entire product line related to capturing at the source of welding fumes or thermally generated fumes. That's an easy one for me to say. So we're going to cover basically two product lines. We're going to cover our portable units and we're going to cover our arms. The arms will go all the way through our ATEX certified product line. Being a Swedish-based company, and I guess I should introduce Netterman a little bit. We are 76 years old. I'm gonna give you the quick version. 76 years old. Global headquarters is in Sweden. We operate on 5 continents. We have 50 offices. Currently a little over 29 or 2,800 employees in that ballpark. We've made some recent acquisitions. Our sister companies include Nordfab, clamp together ducting, Micropool, Microflow, Auburn Engineering, which we acquired just most recently. And we seem to be growing by acquisition, which is a wonderful thing because it brings about other aspects of fume extraction, dust collection to your fingertips via the wonderful group of people at Veritech and Netterman. So thank you everybody for joining. And as Kelly may have mentioned, keep your questions, so the question and answer at the end of the session, and we'll cover everything. We're not obligated to just a length of time. I'll go as far as y'all want to go. Starting off with our little bitty small fume eliminator. This is a small, lightweight, high vac unit. In the weld smoke extraction, you can capture it in both high vac, which is anything that would pick a particle up that falls to the floor, or low vac, which is standard dust collection for fumes that migrate up into the air column. So there's a little bit of difference. The Fume Eliminator is a small portable unit. As you can see here, it's only 90 CFM. However, it's designed for on-tool extraction. It's portable, it's 35 pounds. It's not high noise level. It gives a technician the ability to do repairs and procedures in place where maybe it's inside of an existing building, maybe it's in a hospital, things of this nature where you just can't take and move it outside. So we give and provide a portable unit such as this Fume Eliminator to satisfy those needs. It does have different exhaust or capture nozzles. So we both have, the 200 and the 80. It's just a different shape. They're still the same nozzle. It does come with an extremely long hose at 16 feet. So it gives the worker some flexibility. But in addition, it allows that worker to attach the hose onto what is called an on-tool extraction port. Kelly will share this presentation, and there's a link on YouTube for this Fume Eliminator showing a video. It's pretty difficult for me to jump in and out of this presentation and show you, but it is on YouTube. So as you can see in this, here's a technician carrying both his little portable welder and our Fume Eliminator to go to a specific spot in a facility and do a repair, do some maintenance type work. This is not a 8 to 12 hour a day product. This is a spot weld, a maintenance type position, but it's extremely portable. Next, we're going to talk about our filter cart and our filter boxes. These are our larger low vac type system. So we're looking at the 600 to 1200 CFM range on these, ballpark 6 inches of static. Netterman had a webinar yesterday corporately where we introduced the newest product line for Netterman, which is nano filter technology upgrades to our filter cart and our filter box. A little bit of difference, you heard me talk about the Eliminator as a limited usage type product because of its portability. The main differences between the filter cart, as shown here, and our filter box, as shown here, is filter cart is a limited 2-3 hour a day type because it's a disposable filter. Filter box can be used in production because it is a cleanable filter. So we offer 2 of them, whichever one suits the application best. They're identical from the standpoint of reach, fans, things of that nature, nanofiber technology filters, all of that. The difference is how long you use them in your process. So it was a wonderful upgrade to the system, jumping from MERV 11 to MERV 15. I know some of the national facilities have moved away and moved to higher filtration in their weld, and this opens a door for us to continue to provide products for you all. If you're not familiar with nanofiber, basically nanofiber is just a tighter weave, a little bit more dense than your regular spun bond polyester, capturing particles as low as 1 micron. I'm not sure if you can see on this present. There we go. An average hair is 50 microns. So if you can imagine the size diameter of 1 micron, and you can see by our highlighted, our filter cart on the lower left is now MERV 14. Our filter box is MERV 15 based on filter size. So this was a wonderful upgrade that we've brought about. And we also have these in our freestanding dust collection units, such as our FMC and our MCP and things of that nature. Bob can help you more with that. My partner who was unable to attend for our region today, he's on site, Kevin Ford. He can help you with the dust collection processes. We're going to move now to our extraction arm kits. We offer a nice little product assembly here consisting of an arm, a fan, and a filter, where maybe we don't have the ducting room to put in a full-blown dust collector. Maybe we only need to pick up at 1 or 2 locations, and maybe exhausting the air to external of the building is perfectly acceptable. So we can do this in the 600 to 1100 CFM range, but we can also add one of our MFS, that is a modular filter system, filter cartridges onto it. We have both particle, HEPA, and carbon gas for those applications. So we can even recirculate the air where we are having a process dealing with hexachromium valent. So it's great opportunity there. So we're not exhausting conditioned space sometimes. Sometimes we only have a small application where we do need to exhaust conditioned air. It's just we can adapt to whatever your process is. So this is just one of them. The wording shows telescopic. Unfortunately, I don't have a nice image of the telescopic arm. However, our telescopic arm does reach from 3 foot to 5 foot. We offer it in 3 hood designs, a round metal hood that would look like the end of a trumpet, or as you see on this one, our original hood, we can do it damper or damperless, whichever you would like. Excellent product, and it's very, very low horsepower, low power draw. At 115 amps with a manual starter on site, it doesn't require a bunch of excessive electrical usage or electricians needed. This one's actually showing the original arm, as you can reach up to 10 foot with this. It still stays 600 CFM. Most of our 6-inch arms are rated in the 600 CFM category. Our larger 8-inch arms and extensions boom, as you'll see shortly, will get up into the 1200 CFM range. Here's the filter I mentioned. So in this application, we've simply installed or inserted one of our filters into it so that we can recirculate conditioned air. Again, it's 115 volts, 1.5 horsepower fan. perfect application for a small, maybe even in a repositioned or reconfigured maintenance facility. Maybe they're welding stainless steel and doing this process. We can go ahead and add a particulate, we can add a HEPA, and we can make sure that the recirculated air is perfectly safe for all of those occupying the building. We're going to move up into our larger arm discussion right now. So two of our arms are the two styles of arms, I should say. Our original arm, our telescopic arm, our corrosion resistant arm are all internal skeleton or internal structure. When we get into our next series, whether it's the heavy duty, the medium duty, or the ATEX certified and stainless arms, we run into an external support or skeleton. And that's this part of the arm that I'm highlighting right now with my mouse. This arm is larger. As I mentioned, we get up into the 1200 CFM. This is for a more heavy duty smoke application. Maybe they're only welding with the stick. Maybe they're doing plasma arc gouging, various things of that nature that create a heavier, thicker smoke. Maybe they're actually doing a little bit with a plasma torch, a portable plasma torch. This works perfect for that. We can do this arm on a fan, just as I mentioned, with the CFM capacity, and again, works perfect in an isolated situation, but we also offer this as an arm that goes across the board for your application. These are the various three arms with the ectoskeleton, as I like to call it, our next series. We'll discuss these a little bit heavier detailed. You'll notice the center arm is our original hood, and the right-hand arm is our heavy-duty 8-inch hood. You notice if we got a flat spot on all the bottom of our hoods are designed to where they can actually be set on a surface. The radiuses that you cannot really tell without such as an instrument such as a C&M provide a collection cone or collection sphere, roughly the size of a beach ball. So 16 to 18 inches, whether it's horizontal or vertical, for capturing weld smoke. Source capture is absolutely the most efficient and best approach. You can have ambient collection, which would be basically just like your HVAC in your facility right now, but that causes the weld smoke, the toxic fumes, the hazardous fumes to pass by people into their breathing zone and actually expose other people to sources of pollution that they don't need to be exposed to. Going to again talk a little bit about, so we have the original arm, we have our Nex S, which is stainless, we have our D and DX, which is stainless hood, but it's using an irregular coated ectoskeleton, and then our MD and our HD on the next series. The MD is a 6-inch arm, the HD is an 8-inch arm. So we cover both applications of CFM draw. A little bit, you probably have seen something similar to this. We have a dust collector in line with a few arms. That arm can continue on for however many CFMs is applicable and however many arms we have. We're showing this with our sensor and our automatic dampers, a VFD, the regulator, this is the cat's meow of dust collection, and it's actually the most leads effective and certified approach, where you don't need to run a dust collector at 100% capacity when you only have 2, 4, 6, 8, 10, 25, 30% users. It's a great approach to continuing to meet LEED certification. This is a nice little picture of our telescopic arm. As I mentioned, this arm reaches from 3 feet in the fully retracted to 5 feet. Positional hood can move around pretty much like your hand. If you were to hold your hand out and kind of roll it and twist it, that's what the hood would do. It's a wonderful product for close, tight. I like to put this product myself in education facilities where we're teaching young adults skilled trades, to where they're working in a welding booth that's, say, maybe 5 foot by 5 foot. There's no reason to put a 10, 14-foot arm in there when the space is so tight. Again, it's a 600 CFM arm. As you can see here on the right-hand side, it shows you its various reach positions. And keep in mind now, we're positioning Center line 12 inches off the fixed mounting position. So even though it shows 63 inches, you can actually, if you said from that wall or that fixed mounting position, I need 6 feet instead of 5 feet. Well, I give you 6 feet right there. So by mounting it off the center line. Here's showing our original hood in process. This is a hood that's been around forever. It's a little bit older version. As you can see, the new ones from some other slides have a little bit more rounded feature. It does have a damper in the hood to control airflow. The positioning of this hood, as you can see, is roughly 30 degrees away from the worker. And its source capture, you can see basically there's no escape from air. And again, this is only 600 CFM application. And when we get into our original arms that we mentioned, I can do 7 foot all the way up to 14 feet. 7 is probably the most common. I see a lot of 10 feet in light industry. 14 foot is really reaching for an arm. I don't see the application there. Now you notice there's a white arm. The white arm is what we call a corrosion resistant arm. Its internal skeleton has been anodized to resist oxidation and degradation from any sort of chemical that's not explosive. It's not necessarily causes a health risk. It's just maybe it's going to off gas a little bit and cause aluminum to oxidize. Our skeleton, internal skeletons are aluminum, and they are all controlled by friction joints that can be readily and easily adjusted at the site to control any wear and tear and friction. The beauty of the Netterman arm in the bracket, if the bracket is supported from an overhead beam and not against a wall, every one of our arms has the ability to rotate a full 360 degrees. So if you think about it like a light in your facility, it can shine 360 degrees unless the diffuser is shaped differently. Our arm gives you the most flexibility to rotate and locate positions to work and weld with. We range from 400 to 600 CFM, 7 to 14 feet. Nominal dimension is 6 inches, and it's not extremely loud. We average roughly 70 to 73. This arm is rated at 76 decibels. However, that's extremely quiet in an industrial design situation. As I mentioned, our corrosion resistant arm right there, it's just non-explosive properties. So we may be dealing with something like dry ice, or they may be just anything that might off gas that wouldn't cause the operator to need to wear a breathing respirator, things of that nature. Various components that go with all of our extraction arms. So we offer the standard 1 foot or standard bracket that mounts it 1 foot off the hard fixed surface, but we can also put both a 3 and 6 foot extension bracket to extend the arm out, maybe to hang it from a ceiling, position it off of a floor, the various things. You can see all the different components that go with the different hood styles: spark screens, lights, fan on and off switches, automatic dampers. Mount the fan directly to the arm, mount a silencer to the fan, or even a filter as shown there. But we also do these with centralized systems with your dust collection, or even just a standard exhaust fan. As I mentioned, the various mounting styles. So this gives you 4 options right there. Maybe we need to be overhead. Maybe we need to come from a work surface such as that work table or the floor. But it gives you a lot of dexterity. And even if you're dealing with a higher ceiling than normal, we still give you the ability to not have to require superstructure or additional ironwork given various working heights. We'll talk about our next MD. That's the medium duty. That's again a 6-inch arm. As you can see, you can now see the ectoskeleton, or the external support system. Again, this is our original hood. Red lever right here controls our damper. It has push button for an LED light. You can actually use this also to remotely start the fan. In this application, you can see it supported overhead for the worker at the work surface. Looks like he might be doing a little TIG welding there. So that's actually low fume extraction. If you notice on the right-hand side of the screen, you'll see the indicators for fan and for light. That can be mounted right directly on top of the hood. The worker does not have to leave their workstation to power it on or power it off or add additional light to their working environment. A great little arm. Again, it comes in the variety of lengths of up to 16.5 feet. We do bump this one up a little bit higher to 800 CFM. Just so it gives us a little bit more range. And as you notice, the decibel level dropped by 6 decibels between this hood and the previous hood. Some of the design styles over the years have incorporated a little bit better flow of air to ensure that we lower the ambient working noise in the working environment. And as I didn't mention on the previous slide, the maximum fume temperature is 160 degrees Fahrenheit, which really, you may say to yourself, that doesn't sound very high. Remember, we're incorporating ambient air, so we're reducing the actual temperature of the exhaust gases by 40% within the first 10 feet of this product. So even getting further down the line, maybe the fan's at 10 feet, maybe the fan is 100 feet. This also helps us eliminate the need for a high heat fan. But the gases themselves, or the fumes coming off of a weld, are not necessarily hot, such as the weld itself. Some accessories, as you can see, the Next has a different looking mount. These are a little bit more rigid mount. The mounting cone is slightly different. My extension brackets, whether depending on the length of the arm, have a lot more rigidity. Again, I can do 3 foot and I can do 6 foot. I still offer the same thing. I still have a spark protector. I still have a silencer option. I still have the light fan switch. So we incorporate a lot of the same features throughout our arm products. Just because of the way the arm may be manufactured or designed, some of the mounting styles changed very slightly. Here you can see the welder is using the welding shield to the best of his ability, and his safety glasses are making sure his hair does not get disturbed. Everybody's got a good laugh out of that. But again, it's the 8-inch heavy duty arm. Again, it's an external skeleton. Personally, I'd like to see his welding shield a little closer. This is an 1100 or up to 1200 CFM product. As again, I mentioned 7 to 16.5 feet. So we get a lot of reach. In being 8-inch diameter, it marries perfectly with an extension boom. I'll discuss that boom in a little bit. Noise level has dropped even more significantly. Now we're down to 63 decibels. Because of the transfer velocity that we design around and the CFM value, we're actually able to work at a little bit lower decibel level with this arm by comparison. And I'm not sure how many have been in an industrial facility, but 63 decibels is almost a whisper in a metalworking shop. Again, the same assorted product for accessories, spark screen, automatic dampers, silencers, the various mounting brackets. I mean, we offer the same range of products throughout our welding arm to make sure everybody's an equal team member. I talked about extension booms. So with my 2 extension booms, I have a 14 and a 20 in 8-inch with a flexible and hard duct kit. This enables me to get 34 feet out, or actually 44 feet in some, no, 34 feet. My mistake. In some instances where, let's say we have a large facility where we have overhead crane work and we're bringing large products, whether it may be skid systems, maybe it's equipment, maybe it's vehicles, industrial grade dump trucks. This allows the shop workers to push the arms against the wall, do their overhead crane work, but then still yet bring the arm and the extension boom in to successfully capture all their weld smoke or thermally generated fumes, yet still keep things off the floor and keep a safe and clean work area. As again, I mentioned 14 and 20 foot. The 20 foot's a double pivot. So we pivot also in the middle, but then we rotate against the axis of the wall. When I talked about a hard duct and a soft duct, my flex duct or soft duct is going to be at the wall mount and at my swivel joint. Otherwise, we hard duct the other two. The reason we do that is to keep our static down to the lowest possible inch value. We're trying to lessen how much static, lessen the static, we lessen the horsepower of the fan, lessen the horsepower of the fan, we lessen the electricity required to run it. Wonderful product. Now this one does not pivot 360 degrees. Obviously, it's only able to go 180 degrees off the wall, but the center joint also pivots 180 degrees. Now we're going to get into our next D and DX. We have these products are more designed, as you can see here, for food, pharmaceutical type application and chemicals. This is because of the corrosion resistance of the external hose. Again, this is still an externally supported arm. We keep the internal skeleton away from the product line for various reasons. I can offer this in 7 foot all the way to 16.5 foot. Again, decibel levels are very low here. Even at 600 decibels, we're only at 50, or 600 CFM, we're only at 56 decibels. We get a little higher when we get to the 1000, 1100 CFM up into the 81 decibel range. However, that's still not an extreme amount of noise given a work environment. As you can see, this is a steel helix PVC on fabric hose. Great application for anywhere that we have processed chemicals, food supply, things that could cause an instance. These are grounded hoses. They meet FDA approved materials. The DX is double grounded. So if we're running into something that we may have sparking areas, flammability areas, things of that nature. Just a little bit more safety. Again, similar to the same design as our other necks, we have the external skeleton. We have our polyurethane hose or a PVC hose. We have EPDM gasket material, and then all of the hoods on the D, DX, and S are stainless steel. A couple of the different wall brackets, you can notice those match the same wall brackets as the previous necks models. A couple different applications. One's laboratory, one looks like it's in process. Maybe that's a food, given the fact he's wearing a hairnet, not sure. And then obviously we're looking at a food and beverage type application. So a mixing bowl or a batch process for something, even candy making, for instance. Then we get into our next S. This is our stainless steel. This is an ATEX certified arm in highly explosive environments or very hygienic environments. This one I only have 3 models. I go from 7 to 14 foot, but I do have it in 5-inch and 6-inch. I have it in 5-inch dampered, 5-inch not dampered, 6-inch dampered, 6-inch not dampered. And you're like, John, that's a lot of information. Yes, I know it is, but we want to give you, the design engineer, the option of the proper product for the proper application. Now you notice what's changed on this particular arm is now I've gone to 100% stainless ectoskeleton, and I have a stainless steel, if you can see it, grid over the hood, thus eliminating any product such as a rag, maybe a bag from a food process or things of that nature. We see a lot of the next S in food processing because of its cleanability with the exposed joint and exposed skeleton all being in stainless. Again, 5 inches up to 700 CFM, 6 inches up to 1100 CFM. Our noise rating has not jumped dramatically. We're in the 66 to 71 range right there. That is a wonderful operating range for noise. If you notice, we still do maintain the 160 degree Fahrenheit extracted air. I have yet to see in a food application where we're mixing and blending that the environment is higher than 160 F. If you noticed on the hood, the springs, all of the components were acid proof. I have a project personally going on right now in a beverage manufacturer, and this is just a little side note, just something to think about. This beverage manufacturer, they produce the product that goes to these new soda dispensing machines that you see in movie theaters, where you can pick one of 27 different flavors, and you can add vanilla, or you can add cherry, or you can add orange, etc. Well, the concentrate for their citrus flavors is highly acidic, because of the concentration value it has, and its dispensing amount is in the small droplet size. It's so concentrated. Well, we use the Next S arm because of it being acid proof 100%. It's a great product that goes into places that you might not have thought about before. Here we can see it's in a food processing plant. They're mixing obviously some sort of powder. But it is, again, it's a grounded arm, so that any sort of static electricity that may build up between mixing, dumping, pouring, blending, various things, it's an extremely hygienic arm. So it's a great arm for food processing applications. This just shows our three various Next in the EX, explosive environments. So if you run into things that are in an explosive environment, we are the source to go to. All of our dust collection products and extraction arm products, we have in a ATEX certified version. ATEX is the European standard for fire protection agency. The European standards are significantly higher than the American NFPA guidelines. So the NFPA recognizes anything coming from Europe in the ATEX certification class. So if you're running into something where explosive characteristics are an issue, please do not hesitate to reach out to the team at Veritech, and we'll hook you up with either Bob Hotchkiss on the West Coast, myself, or my partner Kevin Ford here in the Central region to discuss this. And in closing, here's our 3 email addresses. Again, this will be presentable to or saved by Veritech, and they can share it with you. For those of you who are interested in another survey that Netterman may be doing, one of our product line is, we call it EMST, but it's actually vehicle exhaust systems that connect to the tailpipe in fire stations. So whether it's the engineer, the ladder truck, the ambulance, the chief's vehicle, our goal is to source capture the diesel exhaust smoke and stop it from harming and causing issues with our firefighters and first responders. So if you have time coming up, March 25th, we have one at 11 Eastern, if you'd like to sit in on that one. Obviously, let Veritech know, and we'll share an actual link with it. Here, it's just showing you what we have. So in that sense, I'd like to open it up to some question and answer, and make sure that Bob has ability to assist me.
Yeah, can you hear me okay?
Yeah.
Okay, cool. The only thing I just wanted to add, John, great job, man. Really good summary of the source capturing arms and the different things that are available. For those of you that are on the line that are involved in design, engineering of systems, whether it be for a school setting or a manufacturing, whether it's vehicle exhaust or welding or whatever you happen to have, we can absolutely assist in that. We have a full team of engineers back at the mothership in Charlotte. You've got John, myself, Kevin, as you mentioned. We all have design capability. We can do the calculations in terms of, airflow, value engineering in terms of sizing and automation, product selection, and even can drop products into existing drawings. We're working primarily off CAD right now. And then a full, obviously, specs and specifications that we can offer as well too, so you can incorporate those into your design. So for those of you doing systems, we absolutely can help you confirm that the designs are done properly, and confirm the work that you've done as well. That'd be my only addition. So I guess just open up to questions.
So right now, we don't have any questions in the chat box. So if you do have some questions, you can unmute yourself or type them in the chat box. Also, I just wanted to mention, along with the March 25th fire station that John mentioned, we are also having another one of these specific to Veritech and Norman S. Wright Climate Tech in San Diego. That will be April 30th. And I do know that some of you have already signed up for it. It is available on our website to register for. Or sorry, April 29th is one day off. So if anybody has any questions.
What is a good height for the where the Niederman arm turns, rotates at the bracket on the wall? What's a good height so that you, as the welder is extending the arm out, that it doesn't, you know, it's not going to impede, who's going to get his head on it? Is 8 foot a good height for that, or what is your recommendation on the height of the actual where it mounts to the wall?
Okay, that's an excellent question, and I'll address that one for you. Our standard mounting height to the bottom of the bracket is 94 inches. Now, with our arm design, and we have documentation that you can request and we'll share with you, we can only reach a certain height. So I've had a couple instances where we needed to mount the arm lower to ensure that we got to within, say, 12 or 14 inches off the finished floor. However, for your standard work surface, we mounted the bottom of the bracket at 94 inches.
Perfect. Thank you. Also,
Any other?
sorry, just another
go
question.
Ahead. Go ahead.
So
go ahead.
If you have multiple arms, so we just did a design, right? Just did a design where I've got, they wanted to have individual exhaust fans. So so the welder, whoever the user is not impeding with the other welder. They wanted to have 3 separate systems. So we put 3 Niederman arms, and then we put 3 exhaust fans outside the building, which are 900 CFM utility fans. Is that something you typically see, or do you usually see 1 fan for all 3 arms? What is your typical application that you see in a situation like that in a very large welding shop? Is that an application that you see where there's individual fans?
I'll answer it, and I'd like for Bob to input because we cover different regions. What I see in the central zone, and that's New Mexico, Colorado, over to Louisiana, Arkansas, is 50-50. It's budget driven. So in my rural school districts, for instance, that may have 1 agricultural building for both their junior high FFA type students in their high school, and they're putting in 2 or 3 little welding arms, they'll do a fan just like that, just like we have shown here, or as I discussed earlier in the presentation, direct mounted exhaust. It's a little 6-inch diameter hole through the sheet metal wall, and it works perfect. When I get up into my larger new schools that they're designing and building, and even into factories, we're seeing a brand new approach to the vocational education, or as they're calling them now, CTEs. So I've seen everything from 25 arms onto a huge fan exhausting to atmosphere, or into a dust collector recirculating back into the room. So it's really not one answer covers everything. It's really budget and usage driven from what I see. Both are applicable. We have an entire range of fans that run from 3/4 of a horsepower up to over 100 horsepower in some of our other more dust collection, high industrial segments. So Bob, can you cover what you see?
Yeah. So I'll actually just pretty much agree with John. It's a lot of this is preference, customer preference drives a lot of this stuff as well too. When you're talking about 1, 2, 3, let's say 2, 3, 4 arms, individual fans with individual arms with individual extraction, it's just very intuitive. You have a lot of control. You just turn the fan on when you need it. You turn it off. Not a lot of sophisticated controls. Pretty much just a starter. When you start getting up into larger systems, and especially when you're going through a dust collector and not ventilating straight outside, then it starts to become a lot more economical to integrate some controls as well too. So for instance, let's say you're working with a school, a welding school, trade school, what have you, high school. and you've got a 20-arm system, 25-arm system, and it's going through a dust collector. Well, you do not have to size that for all 25 arms operating at the same time. Statistically, and this is verifiable and very, very reliable, that only about 25% of those arms are going to be operating at any given time. It's very hard to convince a welding instructor that that's the case. So you usually design conservatively for 50% of the arms at one time. But therefore you can have the fan horsepower half the size, the collector at half the capacity in terms of volume, and things like that. And the controls required to do that are pretty simple. Some VFDs, some pressure sensors, some dampers in the system, and away you go. So that's a little bit of a longer answer, but when you're talking about 3 arms, individual fans, yeah, fine, no problem. The horsepower required is pretty minimal, and the cost savings of integrating controls be pretty minute. So 50-50, I'd agree with that, for small systems like that.
Perfect.
Yeah.
And one thing I have
Great
seen,
question, by the way.
yeah, one thing I have seen in real life is in an education facility, even in the technical college, the student is tasked with a process. So they go to their booth, they lay down a bead, whether it's a couple inches long or up to 6 inches long, or their various techniques they're practicing on. And they set everything down, they unclamp it, they bring it back to the instructor looks at it. So they might have been in process for 5, 7, 8 minutes, but then they're out of process for 5, 10, 15 minutes. So back to what Bob was saying, a school is never going to be 100% operational as far as 100% of the booths at the same time. It's just, I've never personally seen it, and I've been doing this for a long time and probably have 100 school districts applications that I've specifically done. So it's just the approach to look at.
That would also be a really good example where, hey, just give us a call. Say, this is the size of the school or system that we're dealing with, what's available in terms of controls. How would we accommodate that in terms of duct size to maintain our velocities? What sort of collector do we need? All that kind of stuff. Just give us a buzz. We'll just walk you through it, help you out.
Now, I want to point out something here, because we're talking about source capture, and I talked about our hoods are designed to lay flat on a table. I don't want anyone to confuse a backdraft panel 2, 3, 4 feet wide with various openings, say 3, 4 1-inch wide slots, as similar or the same as having a hood within proximity. When you get into a backdraft panel, the CFM demand to grab that weld smoke at 24 to 32 inches and pull it into that backdraft panel is exponentially larger than a source capture hood. Again, I mentioned we work in a radius the size of a beach ball, 16, 18 inches. Hood's designed to lay flat. Better picture here. As you can see on this next, it's designed to sit flat on the work surface. The various radii that make up our hood actually capture better. So I've done a lot of applications where they have existing backdraft panels and they want to stay with them. It's not the best solution for source capture of weld smoke. I'm saying that from an industry standpoint, and I just wish I could get more people to understand backdraft panels. Yeah, they only take up a space on the wall, but when you're talking 48-inch wide by 1-inch tall slots, 4 to 6 of them in a hood, we start talking about a lot of CFM draw. Any other questions? Nobody, Kelly?
No, there's nothing in the chat.
Well, they're not snoring, so I guess I didn't put them to sleep.
No, that's always good.
Again, thank you everyone at Veritech for facilitating and bringing us such a wonderful, large, well-diversified audience. Again, everyone, reach out to your team at Veritech Solutions. Let them reach out to us. Let us help you shine in your customers' eyes.
Awesome. Thank you so much, John. And then everybody, I will be sending out the link with the video within the next week.
Thank you so much, everybody.
Thank you.
Thank you. Y'all have a wonderful day.
You too.